This is Jacob's Algebra, Chapter 14, Lesson 1, Part 3. So we were working on problem number 8 and did parts B and D. Now we're going to do part F. So looking at number 8F, remember the instructions are to change the repeating decimal into a fraction. So we have 0.2037 and the 037 is repeating. And we need to change that into a fraction. So we're going to let x be equal to 0.2037. Now we have 3 digits repeating. Our period is 3. That means we need to multiply the x by 1,000, 3 zeros. So if we move the decimal place over 3 places, what we have is 203.7037. So we got to do this to make our repeating part line up. Now we're going to subtract. 1000x minus x is 999x. 203.7037 minus 0.2037. Well, our repeating part is 0. 7 minus 2 is 5. We need to write in our decimal. 3 minus 0 is 3, and then you can see there's nothing underneath these others. So it's 999x equals 203.5. So we can say that our x is 203.5 over 999. Now we don't want a decimal in our fraction, so what we're going to do is multiply the numerator and denominator both by 10 over 10, and that will give us 2035 over 990. So now we need to see what kind of number goes into both of these. I'm going to divide the numerator and the denominator. I'm sorry, this is 9,990. I'm going to divide the numerator and denominator both by 5. And what we will get is 407 over 1,998. And that you might look at and think, there is no way that that can be reduced any further. But 407 is actually 37 times 11. And then 1,998 is 37 times 54. So this is actually 11/54. So that is our fully reduced fraction. So remember on this one, you have to write your answer as a fraction. You have to get it in lowest terms. If you don't get it in simplest terms, you are not done yet. This was number 8, which is just like number 15 that I assigned for homework. So you should stop the video now and do number 15 and then come back to see how the next one works. Okay, so let's look at problem number 9. Problem 9 is just like problem number 16 that I assigned for homework. It says the following questions refer to the rational number 2/19. So I'm going to write 2/19 up here at the top. It says how many different numbers, including 0, can there be as remainders if 19 is divided into 2? Well, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. That's 19 different possible numbers that can be remainders since we are including 0. So for part A, our answer is 19. For part B, we want to know if 0 were one of the remainders, what would you know about the decimal form of 2/19? Well, if 0 is a remainder, then you're done. The decimal terminates. So we can say that it terminates, or you can say that it ends. So if you get to a remainder of 0, you're done. You don't have to divide anymore. It has terminated or ended. Okay, part C. What is the greatest number of digits that could repeat if 0 is not a remainder? Well, there were 19 including 0. So if we take out 0, that means there must be 18, right? Because we had 19 and we removed one of those possibilities. That means there's only 18. So that was number 9, which is just like number 16 that I assigned for homework. So you should stop the video now, work number 16, and then come back to see how the last one works. Okay, let's look at number 10. Number 10 says, if x is replaced by an integer, the expression x over 2x plus 1 also represents a rational number. For example, if x equals 7, then we have 7 over 14 plus 1, because 2 times 7 is 14, which is 7/15. And we can punch that into a calculator and get 0.4, and then 6's that go on forever, so this is 0.46 repeating. So they want you to find the rational number represented by x over 2x plus 1 for a couple of different values of x. They want you to find the answer as a fraction and as a decimal. So for part A, we'll do x equals 1. Well, if x equals 1, we write a 1 on top. The double of 1 is 2, and then we add 1. So our fraction is 1/3. And when we punch 1/3 into a calculator, we get 0.3 repeating. So 0.3 repeating is our answer. Okay, part B, let's try x equals 2. So we'll have 2 over 2 times 2 is 4 plus 1. That is 2/5. When you punch that into a calculator, you get 0.4. Okay, part C, let's do x equals 5. So we'll have 5 in our numerator. In the denominator, we'll have 2 times 5 is 10 plus 1. That is 5/11. And when we punch that into a calculator, we get 0.45454545 repeating. So that is 0.45 with the 45 repeating. Okay, let's look now at part D. That's x equals 50. So our numerator will be 50. In the denominator, we will have 100 plus 1. So that is 50 over 101. And when you put that in a calculator, what you get is 0.4950 with all of that repeating. Okay, so question E is, what happens to the value of x over 2x plus 1 as you increase x? Well, we went from 0.3 to 0.4 to 0.45454545 to 0.4950, 0.4950, repeating. So we know that what we're going to end up with is we have an increasing value. So we will say that it increases. Okay, so that is it for this lesson. You should work problem number 17 now, and we are done.